A natural nuclear reactor? Really? Imagine a time billions of years ago. Dinosaurs wouldn't appear for another billion years. The Earth was a very different place. Continents were forming. Life was just beginning. What if we told you that a nuclear reactor was active back then? And not just any reactor, but one created by nature itself. That's the story of Oklo in Gabon, Africa. In 1972, scientists found something incredible there, evidence of a natural nuclear reactor. This wasn't some industrial accident. This was a self-sustaining nuclear chain reaction that occurred naturally almost 2 billion years ago. The discovery sent shockwaves through the scientific community. A natural nuclear reactor, it seemed impossible, yet the evidence was undeniable. Oklo challenged everything we thought we knew about nuclear physics and the early Earth. This wasn't science fiction, it was a real-life scientific mystery begging to be solved. How could a nuclear reactor just happen? It turns out Oklo had the perfect ingredients for natural nuclear fission. The key ingredient, uranium, specifically uranium-235, the kind that fuels our nuclear power plants today. Billions of years ago, uranium-235 was more abundant, and Oklo had a lot of it. But uranium alone isn't enough. You need a way to start and sustain a chain reaction. This is where Oklo's unique geology came into play. The uranium deposit was nestled within a sandstone layer. Groundwater flowed through, acting as a moderator. This moderator was key. It slowed down the neutrons, making the chain reaction possible. Think of it like this. You need dry wood to start a fire, and you need air to keep it burning. Oklo had the dry wood of uranium-235. The groundwater acted like the air, keeping the nuclear fire going. So how did this natural reactor actually work? Imagine a pool table. The uranium atoms are like the billiard balls. Neutrons are like the cue ball. When a neutron strikes a uranium atom just right, it splits the atom, releasing energy and more neutrons. These neutrons then hit other uranium atoms, causing a chain reaction. That's what happened at Oklo, but on a massive scale and for hundreds of thousands of years. The groundwater played a crucial role. It acted as a moderator, slowing down the neutrons. This made the chain reaction more efficient. When the reactor got too hot, the water turned to steam. The steam escaped, slowing down the reaction and preventing a meltdown. Then the water returned and the process started again. Imagine a fire that keeps burning for hundreds of thousands of years, regulating itself. That's what happened at Oklo. It's a testament to the incredible power and elegance of the natural world. Section 4. Lessons from Oklo, a masterclass for nuclear scientists. Oklo isn't just a cool scientific anomaly, it's a time capsule. It gives us a glimpse into how nuclear reactions work over geological timescales. Scientists have learned a lot about nuclear fission, reactor stability, and even the history of our planet from studying Oklo. One of the most significant findings from Oklo is about nuclear waste. Remember how the reactor ran for hundreds of thousands of years? That means it produced a lot of nuclear waste. But here's the incredible part. Most of that waste stayed put. It didn't migrate far from the reactor site. This has huge implications for how we store nuclear waste today. Oklo shows us that natural geological formations can effectively contain radioactive waste for very long periods. It's a natural example of what scientists call deep geological repositories, which are being considered for long-term nuclear waste storage. Section 5. Oklo and the future of nuclear waste. The problem of nuclear waste is one of the biggest challenges facing the nuclear industry. How do we safely store highly radioactive materials for thousands, even millions of years? Oklo provides a unique perspective. By studying how the natural reactor contained its waste, scientists hope to design even better, safer storage solutions. Oklo tells us that nature can be a good architect for nuclear waste disposal. The reactor's waste didn't migrate far because of the specific geology of the area. The surrounding rock formations acted as natural barriers. This natural containment has lasted for nearly 2 billion years. This gives us hope. By understanding the natural processes at Oklo, we can learn to mimic them. We can design long-term waste storage solutions that are safe, secure, and environmentally sound. Section 6. Oklo, a time capsule of nuclear history. Oklo is a remarkable testament to the power of nature. It's a natural nuclear reactor that operated billions of years before humans even existed. It's a reminder that the universe is full of wonders and we are still uncovering its secrets. Oklo is more than just an ancient curiosity, it's a valuable scientific resource. By studying Oklo, we gain insights into nuclear physics, reactor design, and waste management. This ancient reactor provides valuable data that we can use to make our own nuclear technologies safer and more efficient. Oklo, a time capsule from the distant past, holds keys to the future of nuclear science. It's a natural wonder that continues to amaze and inspire us.